Today we're going to continue talking about quadratics. Today specifically we're talking about writing equations of quadratics. Okay? Now there's a whole bunch of notes today that I'm not making you write down because they're already written down in your workbook. Look at page 68 in your workbook. Please look at page 68 in your workbook. Now, last period, I just want to make it clear, last period said to me, when you first showed us that page 68, we knew everything was going to be really hard today. And then after I got through all the examples, they said, nah, it's not. So you can believe them if you want, or you can just wait and figure it out yourself. But this looks like a mess, doesn't it? Whole bunch of letters, whole bunch of words you haven't seen before. But can you just trust me for a minute that it's really not as difficult as it looks? Okay, we'll go through the examples. There's some of them that obviously are easier than others, okay? But let's get through the examples. But before we do any examples at all, I need to make sure you understand what all this nonsense says right here, okay? Think back to yesterday real quick when I said to you, when we were talking about axis of symmetry, and we said, well, this is a line. We need to make sure to write it as such. And we said it's always going to be x equals, because it's always going to cross the x-axis. And somebody goes, always? And I said, well, always? What do you think? Always? Is it always going to cross the x-axis? And you said no, because what if it's a parabola that opens sideways? And I said, well, we're not ready for that yet. Well, today we're ready for that. Okay? So on this page, first of all, there's two main sections. There's a section here and a section here. This section here just deals with vertical axis of symmetry like we talked about yesterday and like you've been used to because you talked about these in Algebra 1. Okay? The bottom half just deals with horizontal axis of symmetry, just if it's opening left or right instead of up or down. Okay? There's some obvious differences, okay? But let's just focus on the top section real quick for a second. Vertical axis of symmetry. All right? Y equals something x squared. Go ahead. This is what we're used to doing. Y equals x squared. That's the parent function we've talked about and everything like that. So this is what we've been used to. The difference is that there's this strange letter right here. Now, we know that it's not really a strange letter. We know it's the letter P, but it's strange because we haven't seen it in any of the equations that we've worked in before. Well, that's okay. Okay? We just have to figure out what it is. It tells us the focus and directrix, except we've never seen those before and we don't know what they are. But it gives us little formulas to figure out each of them. Okay? So as long as we can figure out what they are, and we also need to know what P is, those are not going to be difficult, are they? And last, if it tells us, like we talked about yesterday, if P is greater than 0, well, yesterday we talked about A being greater than 0, right? Because that was the letter we used in the formula yesterday in our vertex form. But here, if P is greater than 0, it opens up. Does that seem logical? If P is less than 0, it opens down. Does that seem logical? Yeah. Okay? So let's concentrate on figuring out what is a focus, what is a directrix, and what does a value P mean at all. Okay? So first of all, what I want you to realize is P. P is the easiest thing to start with. Okay? Here is, well, let's just do them all at the same time. How about that? Okay? Here's my vertex. Do you agree with that? It's the point on the parabola where it changes direction. It was decreasing and now it's increasing. Right there at the vertex, right? Well, this point right above it, in this particular example, it's right below it. Okay? This point that's inside the parabola is the focus. That's the focus. The line that's outside of the parabola, this line right here, is the directrix. See, here's the x-axis right here. This is a whole different line. That's called the line of directrix. The distance from the vertex to the focus is P. Except here's another cool thing. The distance from the vertex to the directrix is also P. So like PP, is that what you want to say? We can make jokes like that. We're in high school, but that can still be funny, I guess. Okay. In high school, I guess we'd call it 2P. What, or not 2P? Is that what you're saying? Okay, great. So many jokes, so little time. So can we just skip the jokes and go to the math? Is that okay? All right, awesome. From the vertex to the focus is what? P. From the vertex to the directrix is what? P. The focus is where in relation to the parabola? Don't think of it above so much because here it's below, right? The focus is below, but where is it in relation to the parabola? It's inside. See, even right here, here's the parabola and here's the focus. Here's the parabola and here's the focus. It's inside. I'd like to be able to say that the parabola surrounds the focus, except doesn't completely surround it, right? That would be a circle or an oval or something like that. But do you see what I mean when I say it kind of surrounds the focus? Okay? Where's the directrix in relation to the parabola? On the outside. It's a line that's perpendicular to the axis of symmetry. Do you see that? Okay? So the focus is a point, right? So we're going to write it as a point. In this case, it's going to be h, comma, k plus p. Whatever h is, it stays right there. Whatever k is and whatever p is, we add them together, and that's the y value of the focus. Does that make sense? The directrix is what? It's a line, right? It's the thing I'm pointing at, okay? But it's a line, so we have to write it as a line. We're going to write y equals something, or x equals something. Like we talked about yesterday, since it's a line, we have to name it as a line, not just a number. Does that make sense? Okay? So do you have any questions about what's on this formula sheet so far? So, does it still look like a mess? Yes. Does it make a little tiny bit more sense? Yes? Okay, good. So let's do some examples and see how well we do then. How about that? All right, let's start with this one. We'll bring this back and refer to it as we need to, okay? I want you to tell me the equation of the line that has a the equation of the parabola that has a focus at 0, 5 and a directrix at y equals -5. Now, you know me, I'm a visual person, so I want to see what this looks like. Some of you can do this without graphing it. I'm going to graph it real quick. Are you okay with that? So my focus is at 0, 1, 2, 3, 4, 5. There's my focus. My directrix is y equals -5, so it crosses the y-axis at -5. So that's my directrix. Well, here's the deal. Now I know exactly which way it opens, don't I? How does it open? How do you know that it opens up? The directrix is below, like outside, and the focus is inside. So the only parabola that I can draw that it's going to surround this focus is going to open up, like that. Okay? Well, if it opens up, I know that I'm using this formula because I have a vertical axis of symmetry, so I have a vertical parabola. You okay with that? So I'm going to recopy that formula into our notes right here. Y equals 1, 4 over p times x minus h squared plus k. So in order to be able to write this equation, there's 3 things I need. Can you tell me what they are? Well, I've got an x squared, so I don't need to worry about that. What are the 3 things I need to know to be able to complete this formula? P, H, and K. Everybody okay with that? Well, how do I find HK? That's the vertex, right? Did they give me the vertex? No, but is it something I could figure out based on what they did give me? Where is the vertex? Isn't it exactly in between the focus and the directrix? Well, if this is the focus and this is the directrix, this is 5 up and 5 down, isn't that my vertex? As 0, 0. So isn't that H and K? So H is 0 and K is 0. What do I have left to figure out? P? What is P again? The distance from the vertex and the focus or directrix, right? Either one. So that should be the same as that, is it? Yes, and what is that distance? That is 5, so P is 5. So now I need to actually write the equation. Y equals 1 over 20. Why is it 20? 4 times 5, right? And then what? X minus 0 squared plus 0. Now, if I leave it like that, is that the correct answer? Yes. Will I get any points off for that? No, it's a perfectly fine answer. Is it the smallest answer, the simplified answer that I could have written? No, what would that be? 1 over 20 x squared. Right? Because x minus 0 is just x, and then that's squared, and then plus 0 is just nothing. So either one of these answers is correct. This one obviously is more simplified. Okay? But this one, it's really easy to see where my center is, right? Excuse me, my vertex. It says 0, 0. It's right there. How was that? Pretty good? One person thought it was pretty good? Oh, 2 people. Excellent. Yes. You ready to go on to another example? Does anybody have any questions about that example? Yes, sir. How did I get P? Well, if you want me to be honest, when we did this in this class, she's the one that got P. She told me what P is. Would you ask her how she got it? Mia. And you just count. Yes, they should. If they're not, it's not a parabola. Okay? Good. Very good. Any other questions? Okay. What if I ask for the equation and I give you this information? Is that enough information to write an equation? Seems to be. Okay. So I'm going to graph it so I know what it looks like. 1, 1 is the vertex. 2, 1 is the focus. Which way does this open? To the right. Doesn't it open to the right? It has to surround the focus, so it's got to go that way, right? Well, if it's opening to the right, I'm using this general form of my equation, aren't I? X equals 1 over 4p y minus k squared plus h. Now I'm going to go back to the sheet for just a second because I need to make sure that we notice something together. You might have noticed it. I noticed it. Can we make sure we all noticed it? When it opens up or down, in my parentheses I've got x minus h. Does it make sense that these two variables would go together? X is the left and right direction, right? H, if we're talking about transformations, that's a horizontal shift. Which direction is horizontal? Left and right. So does it make sense that the x would go with the h? Well, look where the x and the h are in this one. They're kind of far away from each other, but look what's inside. The y and the k, does it make sense that those two go together? Because that's the y value, that's up or down, and the k, transformationally, that's the vertical shift, which is also up and down. Okay? So when these are together, these are apart. But when those are apart, when these are together, those are apart. Is that okay? You think so? All right. So back to this example. Here's the formula that I'm trying to fill in. Do I know any of that stuff? You know H and K. Where do you get H and K? From the vertex. H, K. What else do we have to know? We have to know P. Do we know it? Well, we graphed it, so can't we count the distance from the vertex to the focus? Okay, ready? 1. So P is 1, right? Because that's the distance right here. Oh, look, it looks like a face. Aw. So now when I go to write the equation, it's x equals 1/4 y minus 1 squared plus 1. Any questions? How are you feeling about this? Okay. What if I give you the equation and ask for all this stuff? Ah, I know. Okay. Okay, so first of all, it's y equals, so it's this top one. It's a vertical axis of symmetry. So here's all the equations that we're going to use, all the little formula things that we're going to use. Okay? But before I even use formulas, what do I know that I'm going to need to know? H and K and P. So let's see if I can figure those out. Do I know any of that? I know H and K, don't I? Where's my vertex? What is it? -3 and 2. Isn't that HK? Okay. So all I have left to figure out is P, right? Well, where does P go? Where is it in the formula? Isn't it part of the multiplier out front of the parentheses? Well, I have a multiplier out in front of the parentheses. So shouldn't these two things equal each other if I'm trying to solve for P? So I'm going to come over to the side right over here and I'm going to say -4, which is my multiplier. That should equal 1/4P because that's what the formula is. That's what the multiplier is in the formula. Everybody understand where I got that from? Could you get it by yourself? Okay. Well, if I have -4, let's make this easier on ourselves. Can we do that? Let's put this over a 1. Because if I have two fractions set equal to each other, how do I solve those? Cross multiply. Well, what's 1 times 1? Okay, that took way too long to answer, just so you know. Okay, let's practice again. What's 1 times 1? Excellent. Okay, what's -4 times 4P? That was very good. How do I solve for P? Divide by -16. Good. What is the value of P in this particular problem? Perfect. So I know that P is -1/16. Well, that's going to help because in all these things that I have to fill in, these formulas that I have to fill in, I need H, K, and P. Well, I have all of them, so can I fill it in now? Yeah, let's do it. The focus is H, comma, K plus P. It's a point, right? So I'm going to write it as a point. H, which is -3, right there. And then K plus P. Well, K plus P, K is 2. Uh-oh. Does anybody see our mistake? Where's the vertex? Where is it? -3, -2. Isn't our vertex -3, -2? Oh gosh, we almost messed up. Whew. So I have K is -2 and P is -1/16. What is -2 plus -1/16? Perfect. Negative 2 and 1/16. So the y value of our focus is negative 2 and 1/16. Now, do you like working with fractions? No, but we're going to do it anyways. I don't like working with you guys. No, I'm just teasing. I'm just teasing about that. Just teasing. What about the directrix? The directrix is a line, so we name it as a line. Y equals k minus p. K minus p. K is negative 2 minus a negative 1/16. What happens here? Yeah. So I get negative 1 and 15/16. We could do the decimal to that, but we are not afraid of fractions, so we're going to leave it negative 1 and 15/16. Now I have to know the axis of symmetry. Well, remember what we talked about yesterday? If this is a vertical parabola that's a vertical axis of symmetry, what axis is it crossing? A vertical line crosses the x-axis. Where? Where does it cross? Wherever the x-coordinate of the vertex is. Negative 3. Plus, just in case you didn't see it before, it tells you right here if it's a vertical axis symmetry, it's x equals h, and we know h is negative 3. Is everybody okay with that? Now, why was that problem harder? Because there were fractions. You got to get over that. We're going to be okay if I give you a problem with fractions, okay? Yes, ma'am. So the negative 3, remember I was just saying right here, if it's a vertical axis of symmetry, the equation is x equals h. So I started with x equals, and I went to find h, and that was negative 3. So x equals negative 3. We also referred back to when we talked about yesterday, a vertical axis of symmetry, we say which axis it crosses and where. We go back to the x-coordinate of the vertex, because that's where it's going to be crossing. So x equals negative 3. Do what? It is a positive 3 in the formula, but remember the formula is x minus h. Okay, so if it's minus h, then my h value has to be negative 3, because the minus is in the formula, x minus h. Okay, good question. Yes, sir. Will the focus always be on the axis of symmetry? That may be the best question I've been asked all day. Can somebody answer it for him? Were you asking him a question of yes, or were you telling him yes? Okay, that's fair. Is the focus always going to be on the axis of symmetry? Well, look at our notes. Here's the axis of symmetry. There's the focus. Here's the axis of symmetry right here. There's the focus. Here's the axis of symmetry. There's the focus. Here's the axis of symmetry. There's the focus. Is it? Yeah, it is. The focus is always going to be on the axis of symmetry. Okay? The axis of symmetry always goes through the vertex and the focus. Any questions? So what if this is all I give you and I say, give me the equation? Can you? No. I want some confidence here. Can you? Oh, okay, excellent. All right. So which way does it open? It opens down. So should I be using the vertical axis of symmetry or the horizontal axis of symmetry? Vertical. So I'm going to go ahead and write that equation. Y equals 1 over 4p x minus h squared plus k. But before I go on, what do I want to make sure to write down so I don't forget it? Which way is this opening? Down. So my p-value is going to be negative, isn't it? Isn't it? Since it's opening down? It tells me that, right? If it's opening down, my p-value has to be less than 0, so that means it's going to be negative, right? Okay, so I need to keep that in mind. All right. Do I know anything? We know where the focus is. Where's the focus? 1, 2, 3, 4, 1, 2. The focus is at 4, 2. Do I know anything else? I know the vertex. Where is it? 4 and 3. And if I know the vertex, what else do I know? H and K. In order to be able to complete this formula, what else do I need? P. Do I know it? What is it? What's the distance from the vertex to the focus? 1. Just to check, what's the difference from the directrix to the vertex? 1. So I know for sure that my p-value is 1. My p-value is 1. My h value is 4. My k value is 3. Now I said something a minute ago and then I said it wrong just now. I said for sure that p is negative, and then I wrote that p is 1. What should the value for p be? Negative 1. Well, that was something easy to catch. Well, hopefully we would have caught it eventually, right? We wrote ourselves a note to help us, and that's what helped us. Okay? Now write our equation. What is it? Negative 1/4 x minus 4 squared plus 3. Done. Any questions about this so far? Is it as hard as you expected it to be based on what this looked like? Not really? It's easier than you thought it would be? Okay. But then we get problems like this. And we say to ourselves, what in tarnation is that? Can we use any of that stuff we just talked about on this problem? Does it give us a focus or a directrix? So can we find the p-value? No. We have to think back to what we've been doing the last couple days. Is there any formula that I know that helps me if I know the vertex? How about vertex form? Y equals A times x minus h squared plus k. In order to be able to write the equation of this parabola, what do I need? H and k. Do I have h and k? I do. Here's my vertex. There's h and k. And what else do I need? A. There's a couple ways I can show you so that we can guess properly, except it doesn't work every time. So can I show you a way that works every time? I don't know A, but I know H and K. Wouldn't it be nice if I knew an X and a Y? Oh my gosh, I do. Look, X and Y. They give me another point that the parabola passes through. Guys, do we typically substitute stuff for X and Y? We typically don't. Okay, but this is one of the situations where we want to, because we really need to find A. And we know H and K, but we're also given another point that the parabola passes through that I can substitute in for X and Y. And if I know Y and X and H and K, isn't that enough to be able to find A? You guess? Okay, well it is. Okay, so Y is 1. A is what I don't know. X is 5, H is 3, and K is negative 3. So let's plug all that in and see what happens. 1 equals A times 5 minus 3 squared minus 3. Anybody happen to know what 5 minus 3 is? 2. What's 2 squared? So I have 1 equals 4a minus 3. Yeah, you've been solving equations like this for a long time, haven't you? Add 3 to both sides. 4 equals 4a. Dividing both sides by 4, a equals what? 1. Now I have to actually write my equation. When I write my equation, do I substitute anything for x and y? No. No, I don't. Okay? So I'm going to get y equals, a is 1. Do I have to write it? Yeah, okay, yes. You don't have to, but it's there if you need to. Y'all can go. Go, go, go. X minus h, which I know is 3, squared, plus k, which is minus 3. And that's the equation. Okay? I'm going to keep going on one more example that you might need when you work on your homework tonight. So it'll be on the video. Okay? The one more example that I want to show you has to do with if I give you this kind of information. These are the intercepts, and it passes through the point 1 and 84. You don't know any way to write an equation if you know the intercepts and what point it passes through. So wouldn't it be nice if there was another equation that you knew that had to do with the intercepts? Well, there is, and it looks like this. This is an equation that you would use when you know the intercepts are P and Q. If you know the intercepts are P and Q, this is enough information to be able to write the equation of the quadratic. Okay? Here's P and here's Q. Same as the last example, I don't have enough information to find A yet, but they do give me an X and a Y. So I'm going to substitute everything I know into the formula, and I'm going to know everything basically but A. Y is 84. A is what I'm trying to find. X is 1 minus P, except P is negative 5, so 1 plus 5. And then 1 minus 8. So again, we're just simplifying here. 84 equals A times 6 times negative 7. 6 times negative 7 is negative 42. And when I try to solve for A, I divide both sides by 42. Negative 42, excuse me. And A equals negative 2. Now I have enough information to write the equation. I'm not going to substitute for X and Y this time. I'm going to write Y equals, A is negative 2. X minus P, so X plus 5. Times X minus 8. Whoa. Sorry. Now the cool part about this is that we're done. We don't have to multiply this out. It's not asking us to multiply it out. It's asking us to write the equation of a quadratic, and that is the equation of a quadratic. There's not really a name for this formula. I usually call it the intercept formula or the intercept form, because it's the form we use when we know the intercepts, but not really anything else, like the P value or the A value or the vertex or anything like that. Okay? Does that make sense? Do y'all have any questions? Okay. Peace.